Hello, and welcome back to another video. In today's video, I'm going to show you how to add the Diesel ORM to an existing Actix Web API. This will allow us to communicate with a Postgres database and create persistent data. As you can see here, our API has three routes: get users, get user articles, and create user articles. The first thing we're going to do is set up a .env file. This will house your database URL env variable, and it will be your Postgres connection information. So it should follow this similar format. And next, we're going to install our dependencies. So we'll bring up our console, and it'll just be two different dependencies. So the first one is Diesel, and this is the Diesel ORM, and Chrono, which handles like datetime types. And for Diesel, we need the following features. So Diesel /Postgres and Diesel /R2D2. Postgres obviously allows you to use Postgres specific features, and then R2D2 is going to allow us to create a pool of database connections. So we'll run that, and next we're going to install a couple tools. So the first one is Diesel CLI. So this is the command line interface for Diesel with no default features, and specifically use the Postgres feature. Next up is the Diesel CLI extension. This will copy our database schema into Rust structures. So this saves us a whole lot of time, especially if you have a big database. And since our database is already set up, I will not be walking through how to manually create the Diesel tables, and this will save some time. Next, we need to set up our project to use Diesel. So Diesel setup, this creates diesel.toml and a migrations folder. So this migrations folder is used for your SQL queries. For the purposes of this demonstration, we will not be needing that, but it's good to know. Alright, and the first command for actually setting up our Diesel schema is Diesel print schema, and this will output to source schema.rs. So what this is doing is it's connecting to our database, and it's building its own custom tables and what our Postgres schema actually is. So you can see here we have two tables, articles and users, and then articles has a foreign key relationship with users. So that's where this joinable comes in. The next thing that we need to do is run Diesel ext. So this is the Diesel CLI extension tool, and this will output to our dbmodels.rs. Alright, this issue is something that I don't know if everybody experiences, but I've seen it on the internet. This is because my PowerShell by default outputs text in a UTF-16. So in order to fix that, we're just going to need to run ps default parameter values out file encoding. So this is going to change the encoding of the output to a UTF-8. And now if we run, first let's delete the schema, because this is the one that was causing issues. So we'll run diesel print schema source schema rs again. And then we will run the extension source db models, and you can see that it passed this time. In the schema, you'll notice that it's exactly the same thing, or at first glance appears to be the exact same thing, but here in the db models, you can see that it created the structs that match the tables. So article has an ID, title, content, created by and created on. User has an ID and first and last name. In this DB models, currently our code doesn't actually know what queryable is, and I wish it had added it by default, but we're going to have to import it. So diesel queryable, and then additionally we're going to import serialize from CERD, because we are going to be using these as returns. So for both of these, we're going to serialize them, or make them serializable. So I'm going to close the terminal, and the first file that we're going to create is dbutils. So this will house a couple structs and functions that we will use throughout our app. So first, from Actix, we're going to have to import actor, adder, and sync context. An actor performs a task, and adder is a memory address, I believe. Correct me if I'm wrong in the comments. And sync context allows you to create multiple instances of the same actor for use on multiple threads. Next, we'll import some pieces from Diesel. So the first one is PG connection. This allows us to create an actual connection to the Postgres database. And then R2D2, and from there the connection manager and pool. So R2D2 allows you to create a pool of actors. The first struct that we're going to create is our app state, and this will just house our DB actor that we are passing around to our different routes. Next one is our DB actor. So we just used it right here. But DB actor is just going to be a pool connection manager for a PG connection. So it's just a pool of connections. We need to implement what an actor is, or the context of an actor for DB actor, and the context type will be our sync context, and we just pass it itself. Oh. Lastly, we need to create a function called getPool. This takes in a database URL, which we've defined in our env file, and returns a pool of connections. So create the manager of type connection manager PG connection, and this is just equal to a new PG connection manager, and we pass it the DB URL and return the built manager. So builder.build, pass in the manager, and expect error building a connection. Perfect. That takes care of our database utils. Next step is to actually use this in our main file. So we have a couple more imports. Actix, the sync arbiter again. We need web data. From Diesel, we need to import R2D2, connection manager, and pool again, as well as the PG connection. And lastly, we need to import standard EMV. Alright. Currently we have mod services, our services module, and we need to also create a module for DB utils. This allows us to actually use the DB utils. And from DB utils, we are going to import get pool, app state, and DB actor. In the actual main function, we are going to define a couple things. So DB URL string, and we're pulling it from our environment variables, and you remember that environment variable is called database URL, and error if it doesn't exist must be set. Create our pool PG connection manager PG connection, and we'll call our get pool function and pass it the DB URL, and we are going to clone our actors on 5 different threads. So DB adder, and that is sync arbiter start with 5. So we're making 5 different DB actors, a movable closure, and we'll instantiate our DB actor and pass it pool.clone. And last step for this file is to actually give our application access to the pool. So data new app state, and pass it the DB adder. That takes care of the main file. Now let's take a look at our services again. I'm going to close out a couple of files here. So again, we have our 3 routes. We're going to walk through them sequentially. So for the first one, get users, in order to implement our database with this, we need to first create a message that we are going to send from this route handler to our database connection. Diesel uses what are called messages. This is like a set of data, essentially, that's being queried upon. We'll come over to our source folder and we'll create a new file called messages. We are going to import from our DB models our user struct. So if you recall, we have our user and article structs, And we are also going to import Actix message as well as Diesel queryable result. Query result. So for fetch users, it's going to be very simple. We have to state that it's a message first off, and then the return type is going to be query result, and it will be a vector of users. And for the actual struct itself, super simple, just an empty struct. We're going to come over to our main file again and actually declare messages as a module. And now if we come into our services file again, we will import our new message, messages fetch users, as well as app state and the DB actor. We'll import Actix adder again. Actix web, we're going to also import data. So if we come into our get users route, we are going to take in state, and that will be the app state. We're going to comment that out. We are going to clone a database pool actor. So this will be of type adder DB actor. And we reference state, DB, and clone it. Next, we are going to send our fetch user message to the database, and we're expecting a couple different returns here. So first one is an OK response. It received users, it connected to the database, all that good stuff, and it is going to return OK when JSON is going to be the info. So this will be the list of users returned as a vector. Next, we are expecting an error. Well, it connected to the database correctly, and it got back an empty array. So for this one, we will send back the user not found, JSON no users found. And lastly, catch all. Something went wrong. Wasn't able to connect to the database correctly. So we are going to return unable to retrieve users. So these messages are basically events. So we're telling the database connection to handle the fetch user event. So in order to do that, we need to tell the database how to actually handle that event. So we're going to create a new file here, actors.rs. This will house our event handlers. So first we need to import our user model from our DB models. We need to also grab our DB actor from DB utils. we need to access the schema that Diesel actually created. So schema users DSL for Diesel, I believe, and star. We need to import our message that we created. Messages fetch user and Actix handler and Diesel self and prelude star. So Actix handler is the event handler for this, and then the Diesel import allows us to actually perform the query. So we're going to create handler for fetch user for the DB actor. The result type will be query result, a vector of users, and the handle function. So what this event will actually call itself. We won't be needing to access the message, so we're going to preface it with an underscore. And then this also takes in the context. So that would be the sync context that we defined earlier for actor, or DB actor. And this will return self result. First we need to grab our connection information, or grab a connection from the pool. So self.0.get. So this is grabbing from the pool of connections, and expect fetch user, let's say enable, if I could type, to establish connection. And for the return, we simply do users.get results user and pass it the mutable connection. Next, let's head back to our main.rs and define some modules. So first is actors, which we just created. We need to actually expose DB models as well as schema. And then one thing that I forgot to do was in DB models. So above this created on, since we're not actually going to be returning this, we need to serd skip serializing. So this will just tell serd that just serialize the first 4. It doesn't need to worry about created on. Now let's give our API a test run. So we'll start it up, and we will come over to our Thunder client, and let's try and make a request. And perfect. It's functioning. I've got two users here, John Smith and Jane Smith, ID 1 and 2, and it returns correctly. Now, if when you try to start your API, you encounter this error, process didn't exit successfully, exit code 3. This is an issue with, I believe, specifically enterprise DB. So what you are going to need to do, and if you want to read the entire fix, I came across this the other day. It is using an outdated version of a DLL. So what I'm going to do is I'm going to bring in this libintl 9 DLL, and it'll live right next to Diesel ORM.exe. So it lives right next to the executable, whether in release or debug. I haven't compiled debug, so it won't be here, but yeah, if you encounter that, that's how you fix it. And now it should start right up without erroring. Next, let's create the handler for get user articles. So first thing we're going to do is, over in our messages, we're going to create our message for actually creating user articles, or fetching user articles, sorry. So we need the article struct from our DB models. We need to create a message that returns a vector of articles. Query result vec article. And this message will contain a user ID. Fetch user articles. Pub user ID, and that will be an I32. Over in our actors file, we need to define how to handle that message. So again, we need the article from our DB models. We need the message that we just created, so fetch user articles. And we are also going to import our article schema. Schema articles, Diesel, and this will, like users, we import Diesel star, but for this we also need ID as article, which is as article ID. This is specifying the ID column from our schema file, and we are importing it as article ID because users also has an ID, so it needs to be unambiguous. Alright. Now for the actual handler, we need to implement handler fetch user articles for DB actor. The result will be a query result again and a vector of articles, just article, and then the handle function mute self message. We will use it this time, so we won't preface it with an underscore, and that'll be the fetch user articles message. And then context we are not doing anything with, so we'll just underscore it, and this will return self result again. Again, we need to grab our connection, self.0.get.expect. Fetch user articles unable to establish connection. And now for this piece, we will access the articles Diesel table. we will filter the results. So by default, this is like all rows in the table. Adding a filter is like a where clause in your SQL. So we want to filter on the created by column equals message user ID. So this is saying find me all the article rows where created by has this value. And finally, we'll get results, and those will be in the shape of an article, and pass it the connection. And now we go back over to our services file, and we'll actually implement it. So let DB adder DB actor, so we need to grab the DB actor that we will use, and then we are going to send it the fetch user articles that we created, the message. User ID is the ID from the path. So up here we have it defined let ID equals path.into_inner and .await. Up here, before we forget, we'll need to actually import our message, fetch user articles, and then back in the route we need to define our handlers, or our matches. So okay, info, and HTTP response okay.json.info. So sending back the rows that we found, and then when the connection was made successfully, but no rows were found, not found, no articles for user ID. And we will make this a formatted string, and not found needs to be called. And lastly, if something else went wrong, then just send an internal server error. Unable to retrieve user articles. And one last thing, almost forget, we need to access our, or expose our app state. Remember, our app state holds our DB connections. Before we continue, I actually have two small errors. So here, I was missing an equal sign. And then additionally, in our Diesel dependency, we actually need to specify that we're using the chrono feature as well. So this actually allows, in our DB models, even though we are not serializing created on and sending it back to the user, Diesel still needs to know how to handle that type. So what the timestamps is, or timestamp in time zone is. So now that we have that sorted out, let's come down here and we'll actually start up our API. Now that it's done compiling, if we run, you see that we get back 3 articles for user 1. And then if we do the same query but for user 2, we get back 4 articles, 4 through 7. So perfect. Our fetch user articles is working as expected. Now for our last route, post user articles. So for this one, we are going to first define our message, and this will be this will return the newly created article. So result will be a query result and just an article. And closing parenthesis. So this message will be called create article, and it will take in a title as a string, content as a string, and created by I32. That'll be a user ID. Now let's create a action handler for the new message. So first off, we will bring in the create article message, implement a handler for it, the result will again be query result article, and the handle function itself message create article. Again, we won't need the context of the handler. And return self result. Grab our connection, create user article unable to establish connection. Now, where this one differs, we need to create the structure or object that is being used to insert the new row information. So what we're going to do is we're going to create a new file called insertables, and this is just a personal naming convention. I like to house my insertable structs together. So for this, we are going to import our articles schema, import, I can spell, Diesel insertable, and serd serialize. We're going to derive insertable, serialize, and clone. And we need to reference the table that this is going to be inserted into. Diesel table name equals articles. And finally, the struct new article, and it'll take title as a string, content as a string, and created by as an I32. Come over to our main, and we will create a module for insertables. Go back to our actors, and now we need to instantiate a new article object. So let new article equals new article. Title is going to be the message.title. Content is the message.content. And created by is message.createdby. Before I forget, I need to actually import this, create insertables, and new article. Come back down. And now for the actual insertion. So Diesel insert into, and this will take our new article. The values that it is, insert into takes the table schema, the table that we are actually referencing. So the Diesel star articles. And then the values is new article. And we are going to return the following columns. So article ID, which we defined earlier, is the ID column from the article schema, and we are using the alias because it needs to be unambiguous, as the user also has an ID. Title, content, created by, and created on nullable. So we are returning these, and created on in here in our schema is nullable. So we need to specify that when returning it. Where are we? There we are. And finally, get result. And we're using get result because it'll just return the single row, whereas if you use get results, it returns it as a vector of the specified type. This will be of type article and pass it the mutable connection. Now for the actual use in our services, we need to import the new message, so create article. And we also need to import, no, that's it. Sorry, I thought there was something else. So let's grab our DB adder apps, DB actor. State.asRef .db.clone. And before we forget, state is the app state with our connection pool. Match db.send, create article, and we'll instantiate this with the title that we are pulling from our body.title to string. Same thing for content. And created by. This will be the ID from the path. We'll await it. And for our match types, we will only have the happy path, so it queried the database correctly and found and returned a result. And we will return back the newly created article. All else, we will just return an internal server error and failed to create article. Now let's give it a test. Cargo r-r. We've got it running. We come to our create user article query. So post user articles with user ID 1. And in our body we have title and content. Some really great article, to be determined content. So we'll send, and as you can see, we've received back a new entry, ID 10, some really great article to be determined created by user 1. If we go back to our query for user 1 articles, then you can see down here it is indeed created. And that's everything that you need to know about how to implement a simple Diesel ORM usage into your Actix Web API using Postgres. If you liked the video and you found it interesting and helpful, please remember to leave a like and subscribe. Coming out with new content, usually weekly, sometimes monthly. Next video will be how to use SQLX as a database connection instead of Diesel. So, thank you for watching, and have a great rest of your day.